All right, ladies and gentlemen, in this video we are diving on into Chapter 7, which is all about polygons, and mostly we'll be discussing quadrilaterals through this chapter. But in this particular section, our goal is to be able to find the measures of both interior and exterior angles of any given polygon. In this video, we're going to make sure that we define the difference between interior angles and exterior angles, and we're also going to utilize the interior angles sum theorem to go ahead and use it as a formula to find out what the sum of all of the interior angles are. So let's dive right on in. The first and foremost thing I want to talk about here is, just so we represent what we're talking about with some basic vocabulary, is the concept of diagonals, right? Diagonals just simply mean the segment that connects any two non-consecutive vertices. So what do I mean by non-consecutive? Well, they don't fall right after each other. Like S and T, those are considered consecutive vertices. And that can't really create a diagonal because that's just a side of the polygon. So PS, that would be considered a diagonal. PR, that's diagonal. Maybe I connected one from Q to S, that's a diagonal, okay? But just to kind of keep in mind as we continue. The next thing I want to discuss is to think about the interior angles of a polygon. So what do I mean by interior angles? Well, specifically what we're discussing for interior angles, and let's just say I just use a very basic pentagon, all right, so a very basic pentagon. All right, all of these angles that I'm going to kind of circle on that interior, all of those are considered interior angles, all right, as opposed to, let's say, for instance, we had a triangle, and this angle that I just created right here, all right, that angle X, that would be considered an exterior angle of a polygon. And so right now, we're going to focus on interior angles of a polygon. And I challenge you to pause the video and to see if you can find a relationship between the number of sides in this chart versus the number of angles in this chart, and to kind of give you an idea of what formula can we derive from this relationship of what we're seeing here between number of sides and number of triangles created, okay? So again, pause the video and see what you're going to come up with. All right, well, let's think about this. I'm going to go back to the last screen and see if you see what we're talking about in terms of number of sides and triangles. So for a triangle, of course, we have 3 sides and it creates one triangle. That's where we are right here, and we know that all triangles by the triangle sum theorem have to add up to 180 degrees for their interior angles. All right. Another common one we know is quadrilaterals. Quadrilaterals, we usually know that all of the interior angles add up to 360. Well, let's think about this. We have 4 sides for a quadrilateral, and a diagonal will create 2, right, triangles. It'll create 2 triangles, and continue it on and see what kind of happens. You end up having 5 of our number of sides for our pentagon, and we create 3 triangles. 6 for a hexagon, and we create 4 triangles. Are we starting to notice the pattern? The pattern should be recognized that for 3 sides of a triangle, we get 1 triangle. That's a difference of 2. Here we go again. 4 for a quadrilateral, a difference of 2 in the number of triangles. The number of sides, 5, a difference of 2. And what ends up happening? Well, what do we see here? Well, we see the number of sides minus 2 gives us the number of triangles. And every triangle represents 180. So 2 times 180 is 360. 3 times 180 is 540. 4 times 180 is 720. So what do we really come up with? Well, it's the number of sides, n, minus 2 times 180 will give us the measure of the interior angles of the polygon. So let's take a look at it in terms of a little bit more condensed format. The sum of the interior angles can always be found by taking the number of sides minus 2 times 180. So a very basic example that we have here, I have a 1, 2, 3, 4, 5. We have a pentagon in this example. So we end up saying that we have 5 for the number of sides. N is your number of sides minus 2 times 180. So 3 times 180 is 540.